I want to talk to you about voting systems, particularly the single transferable vote. So you've got a mini election, it's going to be fabricated data, but we're going to look at how we do it. So here are our votes, I'm going to draw them big, and we're going to go first choice, second, third, fourth and fifth. And then for each of these people, CA. So each of these letters represents the candidate that you want to win, and these are all of the results. And we have them in order, in preference, and then this is an individual's vote, this is an individual's vote, this is another guy's vote, all the way until we have, I think, 12 people voting? 11 people voting? Right. And we want two winners, so two winners. So we need to elect two winners out of this set. How do we do it? Right. So this is our raw data. We're going to first create another table. This is going to be storing this data but parametrically. So we're going to say this is candidate A, B, C, D and E, who is everyone's first choice of candidates. So we have one for A, two people for A. For B, who do we have? We have only one person for B, that's this guy at the bottom. So what do? After we do this in rounds, so this is round one, and we're looking for winners to begin with, and that says if any of these get above a special particular number, and this number is called Q for quota, and this is equal to the number of votes, this is the sum of the votes, divided by the number of candidates that we want, so we are 2 plus 1 plus 1. So this 2 came from the number of winners that we want, plus 1, and then plus 1. So the number of votes that we have, so it's 11 over 3 plus 1, 4.66. This is our special number. No one in here is over 4.66, so we don't have a winner. So the next thing that we do is look for the worst loser, who is just like out of the running. So B is the worst. So we get rid of B. B is gone. And then on here, what do? Every time that we see a B, we get rid of B. So B is gone. And then this is the result that we have left. When we say single transferable votes, this is what we've just done. We've transferred. So here, for example, it was its second vote for E, then C, then A as its fourth. This has effectively been taken and shifted up. And then similarly here, B was a second choice. It's going to become this person's second choice. So rather than saying this is first and second and third, we actually just count across in order, skipping over the ones that we've scribbled out. Oh, there's a B here as well. Okay, so we know it's not B. So what do? We do it again. Draw up a new table, which is going to be A, not B, C, D, and E. The number for A is just 1, 2, and the number for E is now 1, 2, 3, but we've actually gained 1 because this is the first choice of this person. So we're up to 4. So we have 4, 5, 6, 7, 8, 9, 10, 11 votes still, which means our Q is still Q is equal to 11 over 3 plus 1. That's still this 4.66 number. Nothing is beating 4.66, so we go for by worst loser. In this case, that's D. So D is out of the running. So we find all of the D's. Here is a D, here is a D. So we now move on to a third round. Now just A, C, and E in the running, so let's just have A, C, and E. So we find our Q again, which is 6, 7, 8, 9, 10, 11. 11 over, we're still looking for two people, so it's 2 plus 1, 3. Plus 1 is the same number as we had before, it's the same calculation. 4.6. Yeah, he's got it. He's won. So one of our winners, we know, got a winner's podium here. One of our winners is E. But he won by 6 and not just by 4.6. So there's actually a difference here. So we have another formula to apply. When someone wins, but they win by more than what they needed to, we can divide up their votes and make things more proportional. So the formula that we have is that we take the votes that were from E and we just shrink them such that E would have won by the right amount. So we have an extra column here, weights. Everyone starts with one weight. In the event of a win, we'd say the new weight new, is equal to weight old, what we had before, which in this case is 1, it might not be 1, multiplied by the amount that you won by, which is our case 6, minus Q over, and then 6. So that's the amount that you won by, minus how much you needed, divided by how much you got, and that's our scaling factor, which, the numbers are pretty easy here, so now the new weight for all of the people that did vote for E is actually going to be 0.2. So these stay 1, this is actually going to be 0.2, 2 recurring, not 1. This is 0.22, this is 0.22, this is 0.22, this is 0.22, this is 0.22. But E is now 1, so E is out of the running. He's not in the running, he's actually got there. So we scribble off all of the E's. So where are the E's? Here's an E, there's an E, here's an E, there's an E, there's an E, there's an E. So these people, these two, that entire column, this entire row, rather, has just been used up. So, whoosh, whoosh, gone, not needed. And we go for another round. We've had a success. So, it's between A and C. Now, if I was a computer, this would be no problem, because, I just multiply by the weights and just do it instantly. But being slow human, I have to go two ones, add, and then you're worth 0.22. 0.22. That's it. And then for the C's, it's going to be 1, 2, 3, add 1, 2. 2 times 0.22, which is going to be 3.44, and you're 2.22. So let's, same again, we find our Q number, which is not 11, because we've got rid of and used up some of these votes. It's going to be 2.22 and 3.44, which is 5.66, and then we're following this formula, but we've only got one place left. So it's not divided by 2 plus 1, it's divided by 1 plus 1. So we're divided by 2, add 1, so our magic Q number that everyone needs to get to, so Q is equal to 3.83. Neither of these guys got to Q, so it's not that C is a winner, it's that A is a loser. We eliminate A, and now we only have one guy left. That makes C the last guy. So it's kind of easy to say that you can get rid of the last guy. In the case of a tie, so say for example D was also 1, we could look through second choice preferences and then figure out who won on second choice, and then go by third choice preferences, and then if no one won, then it makes a difference, but it doesn't matter like how well proportionally represented it is. If you then, there are no votes splitting the difference, you then just pick randomly. But you can always go by second and third choice because you have that data. This weight thing may seem like an extra complicated step, but it just means that if someone wins by a landslide, it just means, say we've got one of these results, and someone won by a landslide. Let's draw this as a bar graph. And then there's 2 other candidates here, so there's 4 candidates total. This guy won by a huge margin, this is our Q, you have to beat Q to win, and he won by a huge amount. So we'd say he's out of the running, and then we'd split it the rest. Sorry, in this example, that is small, and these are slightly bigger. So say that these are both politically affiliated, and these two are politically affiliated. This person would then get eliminated because he is smallest, even though together all of the people that would have voted here second would have then gone here. And then these 2 people wouldn't have got any of the votes, but this being eliminated, it would have gone to one of these. But you need to decide how you want to get all of these extra votes down to here in a fair way. Well, some of these people might have gone over there or gone over to here. But how do you go from too many votes beating Q just down to one of these correct numbers. So you could like just divvy it up randomly. You could just say that we take all of the people past, but how do you know that these people are not these people? Because it could have just been the other way around. So we just use a bit of maths, and that is the formula, like the amount too much divided by this. You then reweight everything, so the votes don't disappear, other than being used up because it was 1 and then you scribble out. Right. So this is the single transferable vote system, and I hope you find it useful. I've got a website that now does all of this for you, but it's really good to understand how this works before you use the website. So, thank you very much for listening, and good night.